Good morning, dear students. My name is Ferhan Mazher, and today is 17th of October 2021. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. It's Cambridge O Levels Physics, and today we have set our hearts to solve ATP paper. We call it paper 4, and today we have selected October-November 2020 4-1 paper. This paper 4 belongs from the zone 1, or you can say the variant 1. So let's start this paper. This paper is of 1 hour, and let me show you the paper. Here we go. So this is the paper we are talking about. 4-1 2020 October November. This is the winter season paper. We call it alternative practical. Okay, so the first question coming up on your screen. A student investigates how the strength of a bridge varies with its width. Figure 1.1 shows the apparatus that the student uses. So what basically the student is using, it's basically 2 wooden supports, and we have a cardboard paper. It's a paper, you can say a card or a paper, and it has certain dimensions. It's 12 centimeter wide and it's 20 centimeter long. The student is given a rectangular piece of the card, which is 20 centimeter long and 12 centimeter wide. The card represents the bridge. The length of the card does not change, but the width is reduced during the experiment. She also has 2 identical wooden supports which are placed so that the gap between them is 16 centimeters. She places the card on the supports to make a bridge. She loads the bridge by placing identical coins one at a time onto it. She places the coin on top of each other on the middle of the card. Suggest why she places the coins in the middle of the card. It's a 1-mark question. You see, when you have put 2 wooden supports and you have put a card on rectangular card on them, that is representing basically a bridge, and you want to check the strength of that bridge. So what she's doing to load the bridge, she's using coins. So she will put the coins in the middle of the bridge, exactly in the middle of the bridge. So why is she putting the coins in the middle of the bridge? Because when you put the coins in the middle of the bridge, the weight of those coins will be distributed evenly on both the supports. Another reason can be that the bridge will be the weakest. The weakest point of the cardboard will be in the middle of the cardboard. If you want to check the strength of a bridge, you need to check the strength at its weakest point. Okay, so let me show you my answer. It's just a 1-mark question, and so why is she putting the coins in the middle? Because the load will be distributed equally on both pillars. So a very simple and a straightforward question answer. Okay. The next question is, she needs to know the mass of each coin. The balance available measures mass to the nearest gram. Describe how the student uses this balance to find the mass of a coin to the nearest 0.1 gram. Because the balance, it cannot directly measure any mass which is less than 1 gram. So because it can measure up to 1 gram, the least count is 1 gram. So it will not be able to measure any mass which is less than 1 gram. So the coin might be less than 1 gram, so or maybe little more than 1 gram. But if you will not directly measure the mass of 1 coin. So for this purpose, what you will do, you will, for example, you take 10 coins and you put them on the balance, and you see what's the mass, and then you divide the mass, whatever will be the mass, their combined mass. You divide that mass with the number of coins. For example, if there are 10 coins, then you divide with the 10. For example, you put 15 coins on the electronic balance, you check what's the, or whatever the balance they are using. I said electronic balance, whatever balance they are using. So you put those 15 coins on that balance and you check what's the mass, and then you divide that mass with 15. So that will give you the mass of one coin. So this is how you can go up to 0.1 gram. Find the mass of a number of coins and divide by that number. A very simple and a straightforward answer. I also tried to explain you the concept. So that was question number 1. It's B, first part. Then, okay, so the next part is, okay, so we have to check from the paper. Let me show from the paper. Okay, so we are done with these 2 parts. Okay, so now we are on this part. Each coin has a mass of 3.4 gram. So a single coin has mass of 3.4 gram. She adds coins carefully, one at a time, onto her bridge until the bridge collapses. She records the number of coins that the bridge holds just before it collapses. She repeats this four more times. The number of coins needed is 16, 15, 16, 14, 15. Find the average mass m in grams that the card can support. Give your answer to two significant figures. So very easily, single coin has a mass of 3.4 gram, and she observed that experiment 5 times. First time there were 16 coins and 15 coins, then 16 coins, then 14 coins and 15 coins. So just add up all these coins, then multiplied with the 3.4, that will give you the total mass. And because this was done 5 times, so divide with the 5. So you will know that which mass was loaded, and after that the bridge collapsed. So it's very simple 2-mark numerical. Let me show you my work. Here we go. So it's showing up on your screen. So the average mass will be, I will add up the number of coins, and they will add up to 76. And the mass of a single coin is 3.4. So 76 multiplied 3.4, and we have done 5 observations. So I will divide with the 5. So the final answer will be 51.68 grams, so which means 52 grams. So this is question number 1B and its second part. Hopefully you have understood. Okay, so the next part is, okay, so this is the C part, question number 1, C part. This is, she cuts a 2 centimeter wide strip from the long side of her card. The width W of the card remaining is 10 centimeter. She repeats the experiment. She compares the results for the 2 widths of the card. So what she's doing, she's cutting the card, making it smaller, and then again she checks that how much load is needed to collapse the bridge. So that's one way in which her method allows a fair comparison to be made. So if she wants to make the fair comparison, the gap, the coins should be in all the experiments. The coins should be placed in the middle of that rectangular card. So that makes sure that every time the comparison will be fair if you place all the coins in the middle of the card paper or rectangular card. Another very important point can be that the coins which she is using, they should be, all the coins which she uses, they should be of the same thickness and same diameter. So that was question number 1, C part. It's first section. The next part is, she repeats this procedure until there is only a 2 centimeter wide piece of card left. Her results are recorded in the table 1.1, and add your value M for W equals to 12 centimeter from the question number 1B, second part in the table 1.1, and that our answer in that part was 52 grams. So we have written here 52 grams. Okay, so the next part, let me read the question first. Okay, so we are done with this part, and we are done with this part as well. Okay, so its second portion is, on the figure 1.2, plot a graph of M on the y-axis against W on the x-axis, and start both axes from the origin. Draw the smooth curve of best fit. So it's a 4-mark question. This W means the width, and that should be on the x-axis. The mass will be the load which collapses the bridge, and that will be on the y-axis. Let me show you that graph. So here we have that graph. Nice. You can have a look at it. So here we have to draw this graph. The width will be on the x-axis and the load or the mass will be on the y-axis. If you look at the table carefully, and you will find that the width goes from 2 to 12. The minimum width is 2 and the maximum width is 12. And the load is going from 5 to 52. So that's the table. So let me show you my work. It's a 4-mark question. There we go. So you can see that on the x-axis, we have taken width, which is measured in centimeters. And here you can see 2 centimeters represents 2 centimeter represent 2 centimeter, 2, 4, 6, 8, 10, 12, 14. On the y-axis, the mass is represented in grams, and 2 centimeter represents 10 grams. So here we have 10, 20, 30, 40, 50, 60, 70, 80. So then I use this table at 2, 5. This is the x-axis, this is the y-axis. X coordinate, y coordinate is 2, 5, 4, 11, 6, 18, 8, 26, 10, 37, 12, 52. So I have plotted these points. And then I will join them with a smooth curve. Okay. So in my next part, you can see that in this diagram, we have joined them with the best fit smooth curve. And I have prolonged this smooth curve because in the next part, third part basically, in the third part, he says, extend your curve to estimate the mass of the coins that collapse the bridge for a card that is 13 centimeter wide. Okay, so I extended this. Our card was 12 centimeters. Then I extended in the same smoothness. I extended this graph. And this is the 13 centimeter width. From here, I went to the graph. And from here, I checked the load. And that is 63. It is 63 grams. So at 63 grams, that bridge will collapse, whose width is 13 centimeters. So this answer is coming from the graph. Okay. So now the next question, he says, that's the D part. He says, suggest how the student can alter the apparatus so that the bridge holds more mass for all widths of the cups. So you can do that by the pillars, the supporting pillars, bring them closer. The gap between the supporting pillars, reduce the gap between the supporting pillars, and the bridge will be able to hold a larger mass. Another thing you can do is use a rectangular card which has a larger thickness. A stronger card can be used. Okay, so put the supports closer together. The supporting pillars, put them closer together. And then he says each student in the class has only one piece of card at the start of the experiment. A second student decides to carry out the experiment starting with a 2 centimeter wide piece of the card and then increasing the width. So just why this causes a problem. You see, they were given a card, a large card, and they, for example, its width was 12, and they performed the experiment and they cut the piece of the card and they reduced the width of the card, and then they measured it. Then they again cut the card, made it smaller, and then they measured that how much load is needed to collapse it, and then they further cut the card and they reduced the size, the width of the card, and they checked how much mass is needed to collapse that bridge. So it's a sensible idea that you are given only one card. You are given only one card. So the sensible thing is that with the maximum dimension of that card, you check the load for the collapse, and then you cut it and you make it smaller, and then you check the load, and you cut it and you cut it and you do the experiment and you cut it, and at the end it will be just 2 centimeter wide, and you check how much load is needed. This ex-student, what he did, he has only one card. He cut it, made it of 2 centimeter width and did the experiment. Okay, so he will get one reading, yeah. But now when he will try to find the reading for a card whose width is 4 or 6, he will not be able to do that because he already cut the card, and there is only one card for one student. So here I have written the answer. He would have cut the card to get 2 centimeter width. For larger width, he will need extra card. So now he need extra card because he has cut already his card. With that card, he can obviously do the experiment for 2 centimeter width, but then he cannot do the experiment for 4 centimeter width or 6 centimeter width or 8 centimeter width because he has already cut his card and there is only one card available for each student. So that's create a problem. So that was the question number 3, E part, and by that we are done with the question number 1. So hopefully you have understood. So let me show you the marking scheme. So here on your screen, I hope that the question number 1 is marking scheme is showing up on your screen. My idea is pause this video and take your time, read all the answers which are given in the marking scheme carefully, because it's very, very important to read the marking scheme. Check your work and compare it with the marking scheme. So you can pause the video. Okay, now I am moving to the next question, and let's see what the next question has for us. So these were the parts, and that was the last part. Okay, so here was that. Okay, so here we have the next question. That's the question number 2. He says, a student carries out an experiment to find a value for the specific latent heat of fusion of ice. He needs to find the mass of ice melted by heater in the time t. He uses the apparatus shown in the figure 2.1. Sorry. The apparatus is this funnel, glass funnel. It has ice cubes. He will put an electric heater here. They are measuring how much current is going by the ammeter, how much voltage is taken by the heater, by a voltmeter, and the ice will melt and its drops will fall into this beaker. This beaker is resting on the balance, and they will be able to measure how much how much ice is melted and converted into the liquid. They will be able to tell this. So hopefully you understand this diagram. And this whole thing is showing up on your screen. Okay, the first question is, the electric heater is placed in the ice inside the glass funnel. State what student must do before switching on the heater. Before you switch on the heater, there might be some drops which fall into the beaker. So the beaker which is resting on the mass, you should note down the mass of the empty beaker. One thing is very important. Another thing is that if there are some drops in the beaker, they should not be there. So you are supposed to wipe them and the droplets of water, if there are some droplets of water in the beaker. And you measure the mass of the empty beaker. This is what you must do before switching on the current, before switching on the heater. So let me show you my answer. So find the mass of the empty beaker. If there are any drops of water, they should be wiped. So hopefully you understand. That was the question number 2A part. And then we have question number 2B part. He says, the heater is switched on and water drips into the beaker. The student switches off the heater after time t. Suggest why the student waits a further minute after switching off the heater before taking a reading from the balance. Okay. So when he, at the end of the experiment, when he will switch off switch off the heater, he, after switching off the heater, he will wait for 1 minute. Why we wait for 1 minute? The reasons are very simple. You see, we allow all the heat to be distributed in the ice, which is in the heater. And so that takes a little bit of time. When you have switched it off, the heat which was in the heater, that should go into the ice. So, or you can say that we allow time for all the water which is melted to drip out of the funnel. So that's why after switching off the heater, you should wait for some time so that all the water drips out into the beaker. So the answer which I wrote is to ensure as much heat as possible is absorbed by the ice. Because when you will switch off the heater, the heater will be very hot and you should wait. So all the heat which is produced by the current which was passing through the heater, that should reach all the ice. This was a 1 mark question. Okay, so the next part is the question number 2B, and its second part is the scales on the voltmeter and the ammeter when the heater is switched on are shown in the figure 2.2. State the reading of the current and the voltage when the heater is switched on. So let me show you from here. That diagram is not that clear, but in the paper, the diagram is very. Okay. So here we have, so this is the ammeter. You can see 1, 2, 3, 4, 5, 4.1, 4.2, 4.3, 4.5, 4.4, 4.5, 4.6. So the reading on the ammeter is 4.6 ampere. Reading on the voltmeter is, this is 8, this is 10, so this will be 7. So 7.2, 7.4, 7.6, 7.8. So the reading on the voltmeter is 7.84. So then he says, using the equation E is equals to IVT, he says, calculate the energy E that has been supplied by the heater when the time is 5 minutes. The heater is switched on for 5 minutes. Okay, so we can calculate the energy IVT. We know the I value, we know the V value, we know the T value. T is in 5 minutes. It should be in seconds. So let me show you my work. Here we go. So the I will be 4.6 ampere, V will be 9.8 volt, and so E is equals to I multiply V multiply T. The value of the I is 4.6. The value of the V is 9.8, and the time is 5 minutes. I will convert this into seconds. For this purpose, I will multiply it with the 60. So it will be converted into seconds. So your final answer for the energy will be 13,524 joules. 13,524 joules energy is produced by the heater in 5 minutes. So that was question number 2B, third part. And then we have the next question. It's the fourth part of the question number 2. It's B portion. He says the mass M of the ice melted in 5 minutes is 36.2 grams. The specific latent heat of fusion L of the ice is given by L is equals to E divided by M. E is the energy we just calculated in the previous part. That's 13,524 joules. The ice which was melted, that is 36.2 grams. So I will just divide them and it will be 373.59. So he says calculate a value for the specific latent heat of fusion, and it's represented with the capital L, and give a unit for your answer. So it will be 374, I rounded it off, and the unit will be energy joule and mass gram, joules per gram. So that is question number 2. I hope that you have understood. So let's move to the next question. I will show you the paper as well, but before that, I just wanted you to show. I just want you to show. So this is that question which we just attempted. Let's see. L we have represents units, and it's a 2-mark question. C part. You just have to give 2 reasons. Okay, so that's the C part. Sorry, I just missed the C part. And let me show you. Okay. So we also have the C part. I just forgot it. Okay, the C part is here. The teacher tells the student that his value is different from the accepted value. Apart from your answer in the A part, suggest 2 improvements to the experiment. The one improvement, can the heat fully immersed in the, so I wrote here heat is heater basically. The word is heater. Let me correct it. So here it is basically heater. Okay, heater fully immersed in the water. So the heater must be fully immersed in those ice cubes. So here don't use the word water. Here we should have written what? Ice cubes. So you can say ice. Okay. So instead of saying the water, you can write ice cubes. And the second suggestion is lag the funnel. So funnel should be covered with some insulating material so that the heat is not lost to the surrounding. Okay. So that was the C part of the question number 2. So we are done with the question number 2. So let's check. So let's check the marking scheme. Okay. So here we go. So my dear students, the marking scheme for the question number 2 is showing up on your screen. You can pause the video and take your time to read this marking scheme, check your answers, check my answers, because it's possible that I make a mistake. But you see, our method is that we always check our answers with the marking scheme. So if we make any mistake, we can correct it. So you can pause the video and read the marks. So we are moving to the next question. A student uses a ray box to investigate the path of light through the transparent plastic block shown in the figure 3.1. The ray of light enters the block at A, reflects at surface PQ, and then leaves the block at B. The A part of the question number 3 is on the figure 3.1. Draw the normal at A. So here with this surface, at this point, I have to draw a normal. A normal, it will be making 90-degree angle with this surface. So here we go. We have this. So you can see this red line, that's the normal, that is making 90-degree angle with the surface at that face and at the point A. So this dotted line represents normal. Then he says, measure the angle of incidence I at the A. So use your protractor. With the help of the protractor, measure this angle between the normal and the incident ray. Check what's this angle. I have checked it, it's 18 degree. Okay. So measure the angle of incidence I at the A, it's 18 degree. Okay. The next part he says, on the figure 3.1, draw a possible path of the ray from A to B. No measurements needed to be taken or calculated. Okay, so everything will be done with the inspection of eye. So you see, when the light will enter into the dense medium like plastic from air, which is rare, and the plastic, which is dense. So what will happen? The light will bend towards the normal because the light waves will slow down, so they will bend towards the normal. So you can see that they have not gone on the original path. They have changed the path, so they have bended towards the normal. So when they will, there no calculations are needed here. So they will touch here, this face. And he said from here they will be reflected. So at this point I draw normal. If this is the angle of incidence, almost same angle of reflection, and I draw this line. It's easy and it's difficult. Okay, so it's not that easy. So that was the question number 3, and we are done with the question number 3. So let me show you the marking scheme. I can show you here. So we are done with these parts. Question number 3 was only 3 marks. We are done with this. So let's have a look at the marking scheme. So this is question number 3 showing up on your screen. The marking scheme of the question number 3. Pause the video and take your time, read all the answers, and then we'll move. Two students determine the speed of sound in air by an echo method. One student stands a long distance away from a tall building as shown in the figure 4.1. This student bangs a drum to make a loud sound, and both students listen for the echo. So he says, state two additional pieces of apparatus that are needed in order to determine the speed of the sound. We need to measure the distance between the drummer and this building. So measure that distance. Let me call it D. The distance is D. And we need to measure this, we need a measuring tape, or you can use a trundle wheel or a measuring tape. So you can measure the distance between the drummer and the building. The second instrument needed is a stopwatch. So when they beat the drum, when they bang the drum, they start the stopwatch. And when they hear the echo, they stop it. So they know from that stopwatch that how much time the sound waves took from going from the drummer to the building, getting reflected and coming back. So on the stopwatch, that will be the time. You see, the sound has traveled D going to the building and again D coming back to the drummer. So if the distance between the drummer and the building is D, the sound has covered in that time, which you have recorded on your stopwatch, the sound has covered the D 2 times. Once it went there and then it came back. So the distance traveled by the sound waves will be 2D. And D is the distance between the building and the drum. The second part, B, which is of 3 marks, he says state the measurements that the students make and how they carry out the experiment to find a value for the speed of sound in air. State any equation used. Okay. 1. they will measure the distance between the drummer and the building, and let me call it D. Okay. Then they will, with the help of the stopwatch, they will note down the time between when they bang the drum and when they hear the echo. So that will be the T. Now, how they will find the speed of the sound? They will divide the distance traveled by the sound with the time. You will find the speed. Very simple. But that distance traveled by the sound will be equals to 2D. D is the distance between the drummer and the building. Because the sound from the drum went to the building and from building came back to the drum. Echo. Okay. So 2D divided by T, that will give you the speed. I hope that I have made my point clear. So let me see my answer. Let me show you. Let's have a look at my answers. Okay. So the tape measure and the stopwatch, these are the two instruments which are needed. Then the second part, B part, with help of tape measure the distance between drummer and building, and let us call it D. Start stopwatch when drum is beaten and stop the stopwatch when echo is heard. Repeat and find average time. Divide distance with the average time to calculate speed. Here the V will be equals to 2D divided by T. Distance is sound. Here the distance is sound traveled to wall and came back. The distance means the sound went and came back. So it will be actually 2D. And D is the distance between the drummer and the building. So here the last two sentences, I think that they are not that clear. But when you write them, write it very clear. So let me show you this is my answer. These are my answers, but let's have a look at the marking scheme. So my dear students, question number 4, which is just a 5-mark question. Its marking scheme is showing up on your screen. You can pause the video and you can have a look at this marking scheme. So hopefully you have read it. It's very important to read the marking scheme. So we are done with this paper. There were 4 questions in this paper. We are done with all of the paper. So my dear students, we are done with the October-November 2020 Physics 5054 4-1 paper. This paper was from the Zone 1. It is a ATP paper. We call it paper 4. The time allotted was 1 hour. And there were 4 questions. We have done all of them. And I hope that you have understood the concept. I always tell you that it's very important to see the video. You should have a hard copy of the paper. And you should also follow my instruction that it's very important to read or check your work with the marking scheme. You see, whenever I do work, I always check with the marking scheme. I never attempt any question whose marking scheme we don't have. Okay, so that's a kind of rule for us. Okay, so thank you very much. I hope this video will help you to prepare yourself for upcoming Cambridge exams. It will help you to prepare your ATP paper. It will help you to prepare your physics paper. So if you find this video useful, please don't forget to subscribe to my channel and don't forget to like my video. If you think that these videos can be helpful, please share the link of this video with your friends by posting them in your Facebook and on your Instagram. So it will be a kind of appreciation for me. So thank you very much, everybody. And it was a big pleasure for me to teach you online. Thank you very much once again and have a good day. God bless you all.